Good day. Today we're going to be looking at writing piecewise functions. If given a graph, how can we write the equation for the piecewise function? The first thing you want to do is determine the domain of each piece. The reason for this, once you have the domain, you can create the function for each part. Now, truthfully, you could do this in either order. You could make the function and then restrict the domain. It does not really matter. However, I recommend this order of doing these rules. Match the following diagrams to their function. As a sort of introduction into writing a function, let's identify what graph goes to which function. The first one says x plus 4 squared. So I'm going to make a little side note here. This is left 4 for a quadratic, where x is less than or equal to negative 3. I'm also going to be looking for a less than or equal to negative 3. Okay, that is not a endpoint, so it's not the graph A or first graph, whatever. That looks good. It is a quadratic, and its vertex is at negative 4, which is left 4, so it quite possibly could be B. There is not an endpoint at C, and there's nothing at all at D. So I'm going to say this function pairs with graph B. Now, as another quick hint, there's only 2 lines here. There are 2 functions here, so really you only had to look at these 2. But anyway. Negative 2 plus square root of x. Now, I don't know if you're like me, but if you are, I do not like the way this looks. I like having the x portion closer to the front and my vertical translation in the back, because now I know it is the square root of x function, square root function, being shifted down 2 units. Now, there are only 2 terms, but I still need to check this graph. So first, square root of x minus 2. Square root of x minus 2, that does start down and it does come up to 4, and it is strictly less than. That part looks good. X minus 5 to the 4th power, this quartic function is being shifted to the right 5 units. And it matches this graph, so they pair together. All right, g of x. I have negative 2 square root 2 of x, where x is less than or equal to 2. Well, I'm going to look for this function to begin with. Negative 2. There is not a dot. Negative 2. There is not a dot. This function pairs with none. This is just none. There is nothing there. I want to tell you, if you were to just be going through these, you can match g of x. Well, let's do that real quick, then I'll continue saying what I was about to. X plus 4, where x is less than or equal to negative 1. It's this unit. The square root 3x and x minus 4 squared both work. It pairs with the third function. If you was doing this, I believe you would very quickly make the mistake and pair, this is in red, do not draw this, pair the first function to this third equation, or third set of equations. These do not pair together. Make sure you are reading each and every one of these functions and looking at the diagrams. So this is also none. So I want you to notice what I've done. I've looked at the transformations of the functions, and I've looked at the function type as well as the constricted domain to pair these. Now we're going to be doing those to write the equations. I have been trying to decide whether to do 1 or 3. 3 is the harder one to do, and I thought about giving it to you to try. But I think I'm going to go ahead and do this one for you and let you use your practice assignment to try some harder ones. So I'll just leave 1 and 2 for you to try on this page. All right, first thing I want to do, f of x. You always want to make this a function. It doesn't have to be f of x, it can be whatever letter you want of x, but it doesn't really matter. I don't mean equals, I mean curly bracket. There we go. I'm going to look now at the domains, because I know I have 3 different functions, because there's 3 different lines. And my domains for the first function is where x is less than and strictly less than 0. My domain for the second function is including 0 and going to 3. 0 is less than or equal to x, which is less than 3. And lastly, this function is anything greater than or equal to 3. Okay. Now let's look at the types of functions we have. In my blue lot circle, this is a quadratic. I know that because of the U shape and because the coordinates are starting from the vertex 1, 1, and then 2, 4. That is a standard quadratic, which is x squared. But I don't know the transformation yet. Well, I do, but I've not determined it yet with you. I'm going to look now at the vertex of this quadratic. My vertex is at the coordinate -2, 0. That is a horizontal translation to the left 2 units. So inside with the x, I need to put +2. The blue equation is x, in parentheses, x plus 2 to the power of 2, where x is less than 0. My green function is linear. So that means I have an x. The slope is down 1, 2, 3, 4, right 1, 2, 3. Is -4/3. And my y-intercept is at 1, so +1. My green function then is -4x/3 +1. For this pink function, it is also linear. Its slope is up 1, right 1, so it's just slope of 1. X is good. I need to find the y-intercept, so I'm going to follow this slope down until I touch my y, and it touches at -2. X minus 2 is the pink function. This is now done. Go ahead and pause the video and try to work problems 1 and 2. Now I'm going to show you the answers. I have tried to tell you the type of function in the first one. I didn't in the second, but I did color coordinate still. All right, that is all there is today. I hope you have a great rest of your day.